Recording in progress.
Hello and welcome. My name is Shannon Kemp and I'm the Chief Digital Officer of DATAVERSITY. We would like to thank you for joining the latest installment of the monthly DATAVERSITY webinar series, Analytics Architecture with William McKnight. Today we will be discussing the data observability advantage, unlocking the secrets to reliable, high quality big data. Just a couple of points to get us started. Due to the large number of people that attend these sessions, you will be muted during the webinar. For questions, we will be collecting them by the Q&A section. And if you'd like to chat with us or with each other, we certainly encourage you to do so. And just to note, the Zoom chat defaults to send to just the panelists. You can absolutely change that to network with everyone. And to find and open both the Q&A and the chat sections, you can find those icons in the bottom middle of your screen for those features. And as always, we will send a follow-up email within 2 business days containing links to the slides, the recording of this session, and any additional information requested throughout the webinar. Now, let me introduce to you our speaker for the series, William McKnight. William has advised many of the world's best-known organizations. His strategies form the information management plan for leading companies in numerous industries. He is a prolific author and a popular keynote speaker and trainer. He has performed dozens of benchmarks on leading database, data lake, streaming, and data integration products. William is a leading global influencer in data warehousing and master data management, and he leads McKnight Consulting Group, which has twice placed on the Incorporated 5,000 list. And with that, I will give the floor to William to get today's webinar started. William, hello and welcome.
Thank you, Shannon. A little bit of echo there. Okay, I think I'm okay. I trust I'm presenting.
I do not see it. No, it's still me.
Okay, hang on. Let me take over. I'm sorry.
No worries.
Okay. Now I think we've got it. Finally. All right. Welcome, everybody. And thank you, Shannon, for the introduction. And I am excited to bring you something that is very hot today. There's a lot of interest in it, a lot of confusion over it as well. So I hope to clear some of that up for you and help you decide if it's right for you and how to effectively wade into this market and find some great use cases where it'll produce some ROI for your company or not, right? So this is really about data quality. So we are strictly in the data quality realm here. So there will be some basics on data quality that I will go through to make sure that we're grounded well enough to talk about data observability, which is sort of a higher plane of data quality, if you will. At least that's how I look at it. Now, I had posted that I'm presenting this topic today, and a friend of mine reached out to me we're very candid with each other, and he said, William, now data observability, you've never met a data tech that you didn't like. You talk about master data management and streaming data and on, graph data and so on. Okay, maybe some of that is true, but I don't think it's completely true. Okay, yes, I did write the book on Hadoop and it was bad timing, but I never really got into cubes or complex event processing or traditional data governance, which I abhor, middleware, in-memory data grids, and metadata management. And actually, I've said a lot about those topics as not being the most interesting and where we should be placing a lot of our value. So take it with a grain of salt, but I do believe that data observability is here to stay. Now, a recent report reveals that over 80% of data practitioners identify data preparation and cleansing as their most time-consuming tasks. That's today. And this is strictly your very, very solidly where data observability will play, as you will see. In fact, these activities consume nearly 40% of their time, a costly investment, especially when considering everything else that they could be doing. It's time spent getting data ready to deliver value. And as we all know, we have to raise the foundation of our enterprises. We're always doing that so that things get automated that can be automated. And furthermore, I will say that we're not all using data quality tools now, are we? And modern lakehouse platforms such as Fabric, Databricks, and Snowflake, data prep and cleansing typically rely on custom code. That's right. Custom code using R, Scala, or Python, and it's often after the fact. This is despite the fact that data quality has been such a problem for decades. Let's explore that a little bit. Enterprise data is still a mess. This is my fear, uncertainty, and doubt slide, okay? So that you wade into my topic. The proliferation of data sources. There's so many data sources today, and there used to be a lot of data in our organization, but now we're saying, well, this is source data. We want this data. We want this data in our data lakehouse, in our MDM hub, in other things. We're starting to really make use of all forms of data in the enterprise. And the data formats that the data is in is more complex than ever. We're definitely talking about unstructured data needing to be at parity with structured data and all forms of unstructured data. And this also includes data that's in many forms of databases, like, of course, relational, but NoSQL, graph, streaming, on and on. The lack of data governance, lack of good data governance. There's still a lot of data governance out there that do not have adequate data governance policies. They're not applying adequate data governance policies. They're coming up with it maybe in kind of a hibernation, if you will, but it doesn't necessarily roll out to the organization. So there's still a lot of work to be done in data governance. And with data becoming more and more important, I think we can agree on that. It's more important that data governance be better than it is. And this hard push into AI that most all organizations are doing. Most of the budgets that I reviewed for coming into this new year, and obviously we all have ongoing budget discussions. A lot of it is about AI. I would say probably a good 50% of the budgets are about AI related projects. And so, with the market growing as it is, enterprise data still a mess. Data quality is a mess, but Gen AI can help. And in a broad sense, data observability does have some correlation here to Gen AI, as we'll see. So now I put this slide up front because I know that a lot of people jump to thinking about this in terms of vendors, right? And there's some confusion in the market. There's Group 1 platforms, and this is what I am talking about today. To be clear, they specialize in data and pipeline health observability. And I'm calling that data observability. They are the subject of this presentation. This group deals with data quality, consistency, freshness, distribution, volume, schema, and things that we'll talk about here today. So I'm talking about who are the vendors? Well, in no particular order and not comprehensively speaking, IBM, Excel Data, Anomaly, Big Eye, Calibra, dCube, Metaplane, Monte Carlo, Precisely, Revify, Telmi. Okay, and there's others. Now, Group 2, which also refer to themselves sometimes still as data observability, are platforms that specialize in infrastructure and data traffic. Now, I think that the two could come together at some point. Now, there we're talking about companies like Datadog, Dynatrace, Elastic, Grafana, New Relic. Okay, you may have heard of those, may be using them, but I'm not talking about them today. They're not data observability in the sense of really focusing on data. Now, I think that data observability tools could actually run the business down the road. Now, you've heard a lot of talk, I've done some of it, about how AI can do more, and AI can actually do more automation, and that AI can be assistance to CEOs, or even be the CEO at some point down the road. I know that sounds crazy, but I think that data observability sits in a position in the company looking at all this data where it can know a lot more than what it is. There's a future here for data observability. I see, and I have no inside information on this, I just see that that merging with BI and AI companies, or maybe AI agent companies, are perhaps the future for data observability companies so that it can step up more in this regard. So watch and see on that. Now, let's talk about data quality. We're all familiar with the uses of data. And when I say we all, I mean our executives, business stakeholders, and us as architects, right? But we also know that below the waterline, there is this big mass of iceberg there waiting, right? It's the data. It's the data. And which of this gets the limited budget? Sometimes it's misappropriated to the uses of the data. Fix this dashboard. How many times have you heard that? Fix this dashboard so that it's right. And so we start fixing the dashboard. But what about the data? So what about fixing the data so that any dashboard can display good data? So we don't have to run circles around in our dashboards and our reports and our KPIs and all the other ways that we're looking at data, right? So be careful of this dilemma that you could easily find yourself in if you're just sitting there taking notes within the organization and just doing what you're told, if you will. Keep in mind where the real problems usually lie. Okay, data quality, it's essential to business success. Now, I define data quality as a lack of intolerable defects in the data. I know, sounds almost like a cop-out, but really that is the definition. When you have tolerable defects, in other words, the data's not perfect, but it's good enough. That's good enough, that's okay. But when the data defects are intolerable, when they're causing business loss, when they're creating a gap to the possibilities, that's a problem. Correct data is a widespread need throughout all of the projects that we're all working on. They all need correct data. Now, maybe they have good enough data, and so they don't say anything about it. But data quality, this thing about data quality, it lacks good, consistent definition. I can't tell you how many times I've been told we have data quality issue, but the person reporting this can't go any further with the definition of this. So we all have so many different definitions of data quality. I'll break it down here today so that conversation can go in an actionable way. So we can get to what are those intolerable defects and where is it happening in this organization so that we can go address it. Tangible benefits accrue from the improved efficacy of the applications, the projects that are using the data. So directly speaking, there's no ROI from data quality, but those projects that are supposedly creating ROI for the company, that's why they're there, right? Those projects should be better with better data. How much better? Well, that becomes the art and science of building out a data quality justification. You see, most people don't care about data quality until it's a problem. All right. We need to care about data quality before it's a problem, because down the line, when the application's in production and so forth, data quality issues are much more severe, are much harder to fix. People are counting on this project now, and you have to schedule things and you have to be very precise about things at that point. Build data quality in, build it in. And it's a slippery slope. Data quality is a slippery slope. If you're at 99% quality, there's a big slide down to, say, 95% quality. Now you're talking about the application might be deemed a success or failure based upon data quality. So investments in data quality yield cleaner data. Okay, great. But let's make sure that they're yielding cleaner data that help projects, not just any cleaner data. Yes, of course, we all want cleaner data, but if you don't put emphasis on it, you might be getting data that the tool thinks is cleaner, but you know it's not cleaner. You know it was okay to begin with. So you have to take a very forthright approach when it comes to data quality. And if you're going to turn it over to the tool, which, by the way, I'm getting a lot better at saying, go ahead and do that with data observability tools, because I've seen the power. And hopefully you will too by the end of this. But if you're going to do that, you still have to audit the results and make sure that it makes sense for your business. We're not trying to beat the data into submission to us, all right? And oftentimes there's not a lot of time to fix the data downstream, right? We want to fix it at the source. You don't need a tool. You don't even need a data quality tool or data observability tool to get this right. Let's say your problem's not that big. Go fix it. You can use SQL. But a tool is, if you're a mid-sized company or higher, I gotta believe that a tool makes sense for you. And I gotta believe also that the tool that makes sense is going to be more or less a data observability tool today. Okay, there is a cost to the enterprise of poor data quality. According to research by Serious Decisions, between 10% and 25% of B2B marketing database contacts contain critical errors. And that's just one example. We've got a lot of data in our organization that we're relying on that we may not even know is giving us grief. It's not allowing us to step up 100% to what this application can do. So we, as data professionals, we need to take that in hand and go out there and make sure the data quality is fit for purpose. Because those kinds of problems, like the one I just mentioned, database with errors, they come to the surface sooner or later. And when it's later, that means that you've gone for months to years of being less than the best. And lots of missed opportunities happened in that time frame. So I've had clients that, for example, can put dollar figures on data records attributable to stuff like failed outreach, losing customers, storage space and effort with duplicate records, incorrect marketing, segmentation, and personalization, and so on. All of this is math. All of this is math. All of this can be turned into return on investment for doing data quality. Now, the benefit of clean data that we just spoke about, it's not enough. You got to turn it into ROI. You got to turn it into some sort of strategic benefit to the company, or the fact that you're lowering the total cost of ownership. I've had data quality justified based upon, well, if we do it in an automated way, it's going to be less than the manual way of doing it. Well, all right, if it works, great. That's one way. But, I'd like to think that we're improving data quality so that the projects are better. We're getting more customers. We're doing better predictive maintenance. We're saving money in terms of predictive maintenance. We're saving in the supply chain, things like that. That's what we want to look for. Data quality should have a value proposition to projects: improved decision-making, efficiency, risk, customer sat, profitability, security, and compliance. Now, all of these are great, of course, but some of you have to take it even further than this and turn it into good old return on investment. We won't get into all that today, but this is a step in the right direction when you see that data quality is tied to one of these factors. Now, where do the data quality rules come from? Well, we can all sit here as data professionals and surmise about what the data should look like, and hopefully we do know something about what the data should look like, but I always turn back to a good data governance program keeps the business interest in data quality and keeps the business input to data quality. It allows the business to have a say in how that data should look, so that when they get it, there's no surprises. It puts a framework around what those rules are going to be that we're going to implement. So everybody talks about data governance. Yeah, it's kind of boring sometimes, but it is important to get it right. It is important to get the business interest and to turn those into actual rules that we implement. Those data governance programs that are sitting off to the side of the business and coming up with rules that never see the light of day, really, and things of that nature, policies and so on that nobody adheres to, things like that, that still happens. That's no good. Okay, we don't want that. Only a methodological approach will work to data quality. It's not a one and done. It's a repeatable process. You want to look for progressive improvement, day by day, week by week, improvement in data quality. It's not an overnight thing that all the data steps up. If you haven't tended to data quality yet, you probably have a good gap to the possibilities, and you want to see that close over the course of time. Probably never perfect, by the way. But my point here is it's not a one and done, and the causes of poor data quality, whatever those causes are, they keep coming in the front door. So while you're fixing the back room, if the door is open, okay, there's more problems that keep coming in. So there's no, you cannot say anymore, well, garbage in, garbage out. I put that data in the lake house that I got from the source, and oh, you're telling me it's garbage? Well, garbage in, garbage out. We can't be saying that. We are responsible for whatever we pass on to our users and our applications. And they think so too, by the way. That's what's more important here. That's what they think. in my experience. So we have to improve upon the data that we're getting and we're making available. And this includes data for training, inference, RAG, fine-tuning, etc. All that data that we're using for machine learning as well. We really need a data quality improvement program. Yes, even around data observability, which we're getting to. But we need this data quality program that defines the quality expectations. Now, I like to quantify the data quality. I like to put an actual scorecard on data quality. You might think, well, that's going too far. I can't do that. I don't know how to put the measurements in place. Well, it'll help if you do. It'll help if you do. Maybe you don't have to share it widely, at least to begin with. But I believe that if you come up with a great data quality scorecard, you will want to share it. You will want the users and applications to know what kind of quality they're looking at in your lakehouse or whatever. So you'll want to profile the data, measure your data quality improvement options, of which usually there's multiple. Usually there's multiple options. You can do it the Lamborghini way, I guess, and go all in and spend millions of dollars on. Or you could put a patchwork in place and improve the quality by, say, 1%. Maybe that's good enough. Okay? It's a constant judgment call when it comes to data quality. Select the best option and improve the quality of the data, which should improve the business. That's what it's all about. Data quality rule categories. Are you doing enough? Well, if you're covering these categories, you are doing enough, because in my experience, all data quality violations come into one of these camps. Now, I'm not going to belabor this, but you can hopefully recognize some of these terms and understand what the violations are, and you want to apply this to all your data. And data observability, which we're getting to, is just so much more efficient at applying this old criteria. It's been around a while. This criteria to all of our data. So let me pick on a few just to be sure that we're understanding this. Uniqueness. Is the data unique where we think it should be unique, like our primary keys and so forth? Formatting. Is the data formatted consistently so that we can look at data over the course of time and do calculations on it, like date or even currencies and things like this? So is it formatted correctly? And we could go through all of these, and I've done that in some of these presentations. It's a lot of fun. It's a lot of fun thinking of these possibilities and understanding that this is where our data quality violations are coming from. Now, we have violations. What can we do about it? The fixing is sometimes easier said than done. We can screen data entry if we can. A lot of organizations don't like to touch those systems, right? That were the airline reservation or the claims processing or the POS system where that data is coming in. We just have to live with it. I remember working for a retailer. This was in the quick service restaurant business, and it's a franchise, so immediately you know that there's some customization going on in the network. But you know, the franchise arrangement is kind of loosey, right? So while they're supposed to adhere to everything that is put out from corporate, that doesn't mean corporate's going to enforce everything, right? So when we learn patterns of, say, store 123, they've customized the keyboard to mean this or that, and those keyboard strokes as we get them doesn't mean what it means in the 99% of the other stores. It means something special. Well, we just live with it. And we've got to be sure we transform that data. And by the way, those franchisees, they didn't have to report to corporate, hey, we're doing this, by the way, so get your systems ready. So we just had to be ready for anything. And I like that approach. Be ready for anything when it comes to data quality. So you can screen data entry, not allow it if you can. You can add different cross-checking so that when the data comes in, you're cross-checking it with your other tables to make sure that this is a valid product, et cetera, et cetera. You can quarantine data, put it over in an area where the so-called data stewards or whoever, whatever you're calling them, the people that might come in, the subject matter experts that might come in and manually review. Okay, that's part of the issue that brings us to data observability. And I'll mention it quickly here that and this comes from 25 years of running a consulting practice, all right? Whenever we try to push back on a client and say, okay, this is going to be your responsibility. You're going to have to review the quality violations that we put right here, very tidy, right here, review them daily, and the system will work, right? It doesn't happen. It doesn't happen. This inevitably other priorities come into place and this thing gets backed up. And I'm afraid that we've been reliant, we, including me, have been reliant on this strategy, over-reliant on this strategy for decades. So are you as well? Maybe you are. Maybe this is where we need a more comprehensive approach that data observability provides. Now, you can also change or repair incorrect data to conform to data quality so that it is fit for use from this point forward, right? We don't always have control of going back and changing source. The source, like I said, the source might be the POS system from the franchises, right? We can't change that. It is what it is. But we can correct it for our analytics downstream. And usually that's what we're bringing data in for. So this brings me to an architectural point. You're doing all this work for data quality, right? Put data quality in a leverageable platform. Quit having all these one-off databases for one-off things. Data warehouses, data lake houses, I should have on here. Master data management hubs, other forms of shareable data hubs. This way you leverage all the data quality work that you are doing for multiple uses, because all of the things you see here, and maybe a few more, are useful to multiple applications. So it's just about leverage. Okay, every project needs a focus on data quality. Hopefully I've established that. And one way that I like to do this is to look at the project list and think about, okay, what subject areas does this particular project need? Like, for example, information-based in-store and contact center, cross and upselling, needs clean customer and product data, and probably a few more. Needs it. So we need to make sure that that data is clean for that project, and so on and so forth. So if you haven't tended to data quality, this is a way to figure out, where do I place my effort now? Where am I going to get the most bang for the buck? And again, we're going to be back to some judgment calls in this process, but at least you have a reasonable approach to go forward into subject areas one at a time and clean them up. Now, what I like to say is data quality should be 10% of the budget for just about every project out there that I've touched in 25 years. It should be, because that's just how much input that clean data is going to have on the bottom line, the purpose of the application. Do I always get that? Absolutely not. Absolutely not. But this is where Dark William comes into play. Dark William will pad the budget and not call it data quality, so that we get data quality budget regardless. Because once I start asking for, let's say, $600,000 for data quality for this project, then that line item comes under scrutiny and it gets hard to justify. But if it just gets baked into the rest of the project and it's just a project necessity, then good enough. As a matter of fact, Dark Williams seems to come out a lot these days. And he's been coming out a lot in these presentations, so much so that he has his own theme music. And here it is. Okay. All right. Enough of that. But it's all for a good cause, for project success. Streaming data quality. Now we're getting into what's special about data observability. What does data observability do that data quality didn't do, or that we're just not doing otherwise? Streaming data is one area. Streaming data has special data quality requirements because it's continuous, where you're continuously monitoring streaming data to identify anomalies, outliers, and deviations from expected patterns. You're doing this in real time. You're supplementing streaming data with additional information from external sources to enhance its completeness and context. And you're tracking the origin, transformation, and usage of streaming data. Efforts prior to data observability have not been good enough for streaming data. So to guarantee high quality streaming data, a robust data quality framework is crucial, which involves real-time monitoring to identify anomalies and potential issues. Real-time data validation rules and cleansing techniques are used to correct errors. So with that as the final slide before data observability, let's talk about data observability now. Now that we've set up the problem statement, if you will. Data observability tools differ from legacy data quality tools. And since this is the point at which I think a lot of us come from, I can say this is true for me before I started my observability journey. What's different? Well, observability tools are much more proactive than reactive. It's automated in its monitoring. It uses advanced analytics, machine learning, and statistical analysis to identify complex patterns. It's real-time and it's holistic. It goes back way further than looking at a narrow slice of the pipeline. So when it comes to managing data pipelines, traditional legacy tools often fall short. Unlike these data quality solutions, modern data observability tools take a proactive approach, detecting issues in real time and automatically monitoring data pipelines for anomalies and changes. By leveraging advanced analytics like machine learning and statistical analysis, these tools can identify complex patterns and issues that might otherwise go undetected. Unlike these traditional data quality tools that focus on data at rest, data observability monitors data from inception through its entire journey in motion and rest. Now, I like to look at tools, and that helps me understand what they do, of course, right? So I hope you can see some of the detail on this one. This is from one of the data observability vendors, Telmi, all right? And it has this concept of drift. And you can turn these rules on and you can customize these rules. But basically, you train it on a data set and you train these rules on the data set. And so the traditional approach to data quality could not do this. It's no longer sufficient for fast streaming data. Data observability is a new approach that's designed specifically for streaming data. And it involves monitoring and analyzing data in real time. So the rules are out of the box. The rules out of the box, by the way, are very good. I could not say this. I have said so many times about data quality tools that they give you rules out of the box that if you follow them, you're basically chasing your tail. You're probably putting effort in the wrong place. And by the way, effort is kind of the key word there when it comes to those data quality tools. Now with data observability, I'm singing a different song. I'm saying I like what observability tools do out of the box. Turn it on, let it go, see what happens. And it's probably going to take you 99% of the way there. Now, the other 99%, okay, or 20% if you will come from customizing the rules. But you can wade yourself into that over the course of time, keeping in mind that data quality should be a moving target. It should be, right? You should go from 50% quality, what have you, to 55, to 56, to 62, week by week by week. And you need a place, you need a way to communicate what you're doing in the data quality area. So that might mean some sort of metadata page, all right? It might mean some sort of corporate communications about what you're doing and so on. But do let users of your data know what you're doing, how you're changing and pulling the rug out from under them in a good way as you improve data quality. Now, in case you can't see some of the things on this slide, it's really amazing. You got business metric drifts, schema drifts, freshness drifts, freshness of data, record count drifts, are the records counting in a way that's reasonable according to historical patterns, etc. Okay, I'm not going to read them all, but this is what hit it home for me in terms of, oh, okay, I see how data observability works by looking at a tool, looking at one of these tools. So start data observability, my guidance is to start it at your raw data, your original data in the pipeline of your enterprise. It's a rapidly growing field that provides comprehensive views of organizations' data. It identifies and does some fixing, not enough, before they become problems. It allows you to fix it right now. Now, I think in the future, and I will get to some futures for data observability in a few minutes here, but I think the fixing is an area that could use some more work in these tools. Go ahead and fix it. It knows what to do. I think some of the reason why the fixing is light right now is because of trust. It's because of trust, because we don't trust tools enough to be fixing data for us, just changing data, even though we give it the rules. We like to take that into our own hands. And I think that will abate over time. And we'll see more automatic environments, automatic pipelines with great data quality as a result of data observability. Data observability also uses automation and orchestration and AI, and it works on edge, on-premises, hybrid, and multi-cloud environments. You see, there's the Gordian knot of data observability in that it's exposed to all this streaming data, all this real-time data, all this big data, may I say, that there's so much of that data, it's just irrelevant to any data quality issues. It's so irrelevant that if we were to go about it any other way, and I have, you just do not find your way to the relevant points. So the difficulty is filtering out irrelevant data and identifying the critical signals that require attention. That's what these tools do. They're so fast, they're so comprehensive, they can do that. And by the way, as I said, Gordian knot, I had to look it up because I'm just that way. So the Gordian knot was said to be so complex that no one could untie it, despite many attempts. The knot was made up of multiple strands that were woven together in an intricate pattern, making it impossible to identify the beginning or the end of the knot. So do you know who famously solved the Gordian knot? Supposedly, okay, the legend is Alexander the Great solved it. But instead of trying to untie it, he drew his sword and cut through the knot. And that solved the puzzle. There you go. Now you know. Data observability for AI. Because I mentioned before, a lot of us are doing AI. And if something doesn't work for AI, frankly, it's a no-go. That's a showstopper for today. And data observability does work for AI. It ensures AI reliability. It's a critical aspect of data quality for AI because traditional methods of managing data are no longer sufficient because there's too much data to manage manually. Anomalies and inaccuracies can easily happen without anyone noticing. And the longer a data issue goes undetected, the longer AI conclusions will be inaccurate. So the benefits of data observability to AI, data validation, data integrity monitoring, an alert system, and rule-based validation. The rules may come from out of the box. They may come from you. And you'll definitely want to take a look at the rules that are out of the box and understand the possibilities with data observability and customize them to your particular situation, your particular profile of data. And one of the key things that helped me to understand data observability was this phenomenon known as data drift. Data drift. It can be much harder to identify over the course of time, really somewhat unidentified prior to data observability. But sometimes data drifts in a way that, of course, it's right, but it's a flag to the business. Okay, why are sales 5% lower yesterday than they were, say, a year ago? Maybe not something you would necessarily see otherwise. But if data observability can raise this issue to the business subject matter expert on this, then maybe something can be done about it. This is why I said before, I think data observability is sitting in a great place to do a lot more for the business. And so watch this space. Use cases, recommendation systems, AI-powered workflows, machine learning applications, foundational model training, customer interactions with chatbots. Really, it's a lot of whatever we're doing with big data. And these are some of the big things we're doing with big data today. Now, as data observability goes forward, the near future, and I say near, because I'm talking this year or next year, we're going to look at more multidimensional anomaly detection. I'm going to talk about that more on the next slide. So, adaptive and intelligent to evolving activity, using AI to detect unique patterns that rule-based systems cannot. It will adapt continuously without manual tuning. So it will learn by observing our data, and it will keep up then with data behaviors. This adaptability helps it in finding the hotspots and the correlating factors that affect data behavior. Enhanced efficiency in identifying issues. With the volumes growing rapidly in data, conventional quality and validation checks are becoming insufficient. The tools will identify high-risk data segments automatically. It does that somewhat today. And correlation to root cause. It will perform root cause correlation. I mean, it's sometimes pretty hard to get to root cause otherwise. To link various issues like infrastructure failures, pipeline breakdowns, data spikes, budget overruns, unusual access patterns, and upstream data problems to pinpoint the source of errors. That's a lot of information to digest to really get to the source of the error. Well, these tools can do that. More design with human in the loop. More automation, to be sure. More forecasting business impacts and issuing alerts are possible, but more design with human in the loop, and this is going to be true for a lot of the tools that we're going to be using going forward, right? Humans are going to be involved from the configuration of agents to managing the outcome, and the standard agent capabilities can be modified. So in essence, this advancement allows data management systems to move beyond simple single-dimensional checks to proactively identify complex hidden anomalies across vast and dynamic data sets, leveraging AI and correlation to understand context and pinpoint root causes more effectively. All right, that's a mouthful. Multiple dimension anomaly detection. This is really expanding the horizon, if you will, of the data that it's taking in to do all the things it does. Hidden anomalies, simultaneous evaluation of attributes. When you have a broader horizon, you can see more in terms of what's going on in the entire concept. Say you're a bank. So you can look at, are there simultaneous transactions going on that are suspicious, for example? You see, data observability actually provides much more direct business function than data quality tools ever did. Detecting interdependencies, understanding context, and spotting complex patterns. So an example of this might be, and I'll stay in banking and financial, but detecting a credit card account showing transactions in locations that are hundreds of miles apart at the same time. This is an anomaly that requires looking at both location and the time data together at the same time. All right, now, we at my firm, Ignite Consulting Group, this year, was it this year? I think it was earlier this year, we published a report, a comprehensive report on the data observability market, where we took the top 10 vendors through the paces, and we graded them out in a few ways. I'm going to give you the link to that in a few slides here. But in doing so and grading them out, what did we grade them against? We came up with the critical capabilities for data observability in the area here first of data lineage and pipelines. So those critical capabilities, and you'll want to look for these, are lineage visualization, impact analysis, and pipeline monitoring. Pipeline monitoring is optimizing operational efficiency and ensuring transparency in the pipeline. It helps identify delays, bottlenecks, and errors, enabling decision-making and tracing issues back to their source. Effective monitoring uses metrics and alerting systems for timely action. The second area of 3 is data quality and monitoring. The capabilities that you want to have are alerting and notifications, data monitoring dashboards, and data validation rule completeness. And these are all detailed in the report, so I won't belabor them here. The third area, real-time data processing and analysis features. This includes real-time anomaly detection, must work in real time, automated metadata collection, source and API completeness. So does it touch on all the sources in your environment, preventing blind spots? API completeness focuses on programmatic accessibility, enabling seamless integration with existing workflows. This synergy benefits proactive issue detection, improved root cause analysis, enhanced data lineage understanding, streamlined workflows, and seamless integration with existing tools. And finally, machine learning capabilities. Machine learning integration in data observability tools can transform from reactive monitors to proactive partners, automating anomaly detection and so on, allowing for faster response times, identifying subtle issues, hard to find issues, and predicting potential issues before they occur, ensuring data pipeline continuity and minimizing downtime. Now, I have for you my old data quality model, updated for data observability possibilities. Because now with those possibilities, the 1, 2, 3, 4, 5, the levels shift completely, don't they? Because now the possibilities are so much more in terms of what we can do around data quality. But the labels remain the same. Level 1, ad hoc, reactive, no formal observability, basic awareness, no formal processes. Some of us are still living that way. Okay, it is really time to move beyond that. As a matter of fact, the numbers I got are backwards here. Number 1 is ad hoc. But anyway, we need to get to level 3, managed. You need to get to level 3, I think, as an organization. I think it's critical to your organizational success to be at that level with your data quality. At least some of you need to be at 4. Some of you need to be advanced. What is shown as 2 on the slide. Sorry about that. But level 2 is foundational. Okay. Initial metrics and tools in place, manual data quality checks. Level 3 is managed, which I just mentioned. Let's get to active monitoring and incident workflows, automated anomaly detection. Okay. Level 4, advanced, predictive and scalable. Predictive models anticipate data issues and end-to-end data pipeline observability. And level 5 is optimized. Fully automated monitoring and remediation with observability embedded in CI/CD. Now, what does that mean? It refers to integrating data observability into CI/CD pipelines, right? Automated testing, early issue detection, streamlined workflows. By embedding, organizations can ensure data quality and reliability are built into the development process rather than being an afterthought. So, with all that, here is the URL. I put it into a short URL, and this is the page that you will get to if you enter that URL, and you can download that paper. And in that paper, I talk about all this stuff, including all the criteria that you'll want to use to look at your data observability market and to select your tool and what the tool should do and what their strengths and weaknesses are of each of the top 10 of the data observability tools. In summary of this presentation, remember this: data quality is never an accident. Still today, not an accident. You have to attend to it. You have to put cycles and budget into it. It's becoming part of data observability. The traditional approach to data quality is no longer sufficient for fast streaming data. It's data observability. That's the new approach. And next year it won't be new anymore, but that's the approach that's new today, that is designed specifically for modern data. It involves monitoring and analyzing data in real time. A lot of opportunity in the data observability marketplace. I expect there's going to be some action there over the next year. And I expect that as a domino falls, that others will fall as well in terms of consolidations with BI, AI, and AI agents, and so on, all in the mindset of running the business more, because nothing, not the AI agents I've seen, of course, one of their selling points is they have access to all this data and they can continuously monitor and so on. Yes, they can, of course, they're great. And we're going to be talking a lot about AI agents as we go forward, but nothing has access to the data like data observability. So when you can bring the data of data observability together with the AI agent processing of all the enterprise applications, you've really got something there that's next level. So we'll see. Data observability prevents errors and automates monitoring. Enterprises should consider the complexity of their project scope and technical environment. In other words, make it fit for purpose, make it right, and utilize the quadrant framework, which I put in the paper. Data quality enables reliable decisions. All right. That brings me to the end of the formal part of the presentation. Shannon, do we have any questions?
William, thank you so much for this great presentation. And if you have questions for William, feel free to put them in the Q&A panel. And just to answer the most commonly asked questions, just a reminder, I will send a follow-up email by end of day Monday for this webinar with links to the slides and links to the recording. I put the link to his paper in there and to the chat as well. So check that out and we'll get that into the follow-up email as well. So, William, this came in early, and your paper will answer a lot of this, but for clarity, do you have any example of a data observability tool that meets the requirements and standards in your reference? Highlight what qualifies the product for data observability.
Well, yes. That is what the paper's all about, really. It's a quadrant-based approach. So in the upper right quadrant, we're all familiar with that, right? You will find, I think, 4 or 5 tools that meet the criteria and make a lot of sense for you today. Now, I'm not saying the other 6 don't. They do as well, but their strengths and weaknesses are outlined in the paper. It's not really something that I can even start to get into here in terms of naming vendors, because that just becomes a really long conversation. But get the paper. There are several tools that are ready for you today.
I love it. And there's a lot of questions, just about tools. So I'll put the link. I know one person was having issues with the link, but we'll see if we can get that resolved for you. And we'll get that out.
If there are issues, I'll get it. We'll get it resolved in the email that follows.
Yeah. I'll give everyone a minute here for any additional questions. Is there one product you recommend for enterprise platform?
Yeah, kind of the same question, isn't it?
Yeah. So, yeah, again, I'll put the link in the chat there. I know everyone just wants to know what's the best tool, which is great.
I know.
So it's very timely.
Yeah, that's and while I definitely respect that question and kind of why we wrote the paper, but just everybody remember that just getting the right tool for you isn't the full job. It's a start. It's a start of really fixing your data quality issues from start to finish throughout your pipelines, throughout your major data sources, proactively and real-time data, streaming data, and so on, for all the purposes. It's a lot of work that's still going to be involved after you get the tool. I'm not saying don't get a tool. I'm saying get a tool, because the work will be just tremendous, and you just won't do it otherwise. Really, you won't do what is required for today's analytic architectures without a data observability tool. That is, if you're I would say a mid-sized company or larger. Smaller companies, you might be able to get away with it if you take a very mindful approach to it, and you take this systemic approach that I talked about earlier in the presentation, where you find out what data is causing the errors and you set about to fix that, and you're fixing errors that help improve the efficacy of projects. So anyway, yeah, I just want to be sure that we know getting the tool is the start.
Absolutely. I just put the raw URL in there. Someone mentioned they had a problem with redirects. So so you have that in there as well. Well, William, thank you so much for this great presentation. It is such a hot topic, and a very important topic. As I was mentioning that our trends in data management survey recently mentioned a lot of people are going to be implementing this in the next 1 to 2 years. So very, very timely.
Indeed.
Yeah.
All right.
Yeah. So thank you. And thanks to everybody for being so engaged and everything.
Bye-bye.
Bye, Lynn.